Hey there, this is KHADER Electronics Made Easy. Today we'll be making this rechargeable smart light which will turn on when there is no power in the home and the room is dark. Let's see how. So let us see the circuit first. The whole circuit gets the power from a USB connected to the charging module. This is used to charge the lithium-ion rechargeable battery in our circuit. This is the charging module used in our circuit. The board has 2 input and 2 output pins, where the 2 output pins should be connected to the battery which we should be charging. Here we are using this lithium-ion 18650 cell. From the battery, the 2 output wires go to the full circuit. But apart from this, there's one more wire which we are taking from the input positive pin of the board. This is connected to the IR LED which we'll be using in the optocoupler. Here we can also use a resistor of around 330 ohms in series to protect the LED. Apart from the battery and the module, the main circuit includes 2 transistors. One transistor is used to switch on and off the LED, which is the light source, and the second transistor is used to switch on and off the first transistor. Coming to the first transistor, there is a 12K resistor connected to bias the transistor, and there is an LDR connected from base to ground. When light falls on this LDR, current flows from base to ground, switching off this transistor and the LED. When there is no light, LDR becomes open circuit and current flows directly from VCC through the resistor to the base of transistor, switching on the transistor and the LED. Say for example, the room is dark. Then it will check for the second condition, that is the optocoupler. This is an AND condition circuit where it will check for 2 conditions, that is, one is the LDR to detect light and the other is to detect power using this optocoupler which we are going to design. When there is power coming in from the USB, it will switch on the IR LED which is connected here. This will incident light on the photodiode which will start conducting current from VCC to the base of the second transistor. And this transistor will switch on and conduct current from the base of the first transistor to the ground, switching off the first transistor. Then the LED will be in off state. When there is no power coming in from the USB, the IR LED will be off. This will stop photodiode from conducting and the second transistor will be switched off, which will switch on the first transistor and the LED will start glowing. All this is considered based on the condition that LDR is already off state because the room is dark. If the room is having light, then anyways the LDR will switch off the first transistor. First we'll start by building the optocoupler. For this we'll be needing the IR LED, IR photodiode and a small piece of heat shrink tubing inside which both the IR LED and IR photodiode will be fixed. Heat shrink tubing does not conduct light, so this is an advantage for us. Before fixing the LED and the photodiode inside the heat shrink tubing, make sure you put some marking on one of the pins so that it will indicate which pin should be connected to the positive connection. Next, coming to the battery, we are using a LG 18650 lithium-ion cell which has 3 wires. The white one is for thermistor and the red and black are the positive and negative. If you are using a cell like this, then it will have only positive and negative pins, which is a simpler one. In our case, we won't be using the white wire, we'll be using only positive and negative wires. Coming to the things required, we'll be needing an optocoupler which we already designed, an LDR, 2 transistors, We'll be using here BC547. You can also use BC548, which is also the same, and we'll be using a 12K resistor. You can use from anywhere between 10K to 12K resistor for this. If you see the circuit, I have used a potentiometer here in series to the LED, which is used to control the brightness. This can go up to 4.7K resistor. Here I am using an onboard resistor, which is a 4.7K potentiometer, like this one. Apart from this, you already know that we are using a lithium-ion battery of LG 18650 and an LED, which is a 1 watt LED. This is a milk white color. You can also use warm white based on your need. For charging the battery, I am using this charging module, which is a USB charging module which I got from Amazon. This costs anywhere between 90 to 100 rupees and it works pretty well. It also has indications of charging and fully charged. First I have built the circuit on breadboard and tested it. I have also tested the brightness of the LED based on the position of the potentiometer which we have connected. I could see that full brightness the LED glows very well and is quite bright. Next I have connected the battery and the charging module and tested it again if the battery was charging, and it was working very well. Let's continue to prototype it on the PCB. One more point about the charging module is, when it's charging it indicates that with the red light, and when it's fully charged it indicates it with a blue light. I soldered the full circuit onto the PCB. Also it has the battery, LED, charging module and the LDR. If you see, I have left some wire on the LDR so that it will be easy for me to fix it anywhere. I have also attached a switch to the circuit so that I can switch it on and off whenever it is needed. I have tested the full circuit before proceeding with fixing it into any container, and it was working well. So this is the container which I am going to use for the cabinet. As you can see, I have sanded part of it, and after completing the full circuit inside the container, I will be sanding the whole circuit just to give it a dim look. And I will be fixing the charging module first at the bottom, then the main circuit will come at an elevation. I will fix the switch to one side of the container and also the battery. I have stuck some insulation tape on the back of the LDR to avoid light from LED reaching the LDR. So I have fixed the whole circuit inside this container and tested it, And if you see, I have made holes for the charging module's USB pin, also the LDR and everything. And before fixing it, I would like to sand the whole container slightly so that it will give a diffused look to the light. I'm using 100 grit sandpaper here so that it won't tear apart the container. Once completed, I have connected the USB to the light and kept it for charging. If you see, this charging is indicated using this red color light, and once fully charged, it will turn blue color. Now let's test it for one final time. I have switched off the charging and the light, and I see that it's glowing pretty bright. Now let's slowly turn on the charging and see if the light switches off automatically. And if you see, it switched off and went into charging mode. Now switch off the charging, and if you see, the light switches on. There is a slight delay between switching off the power and the light coming up. This might be due to the capacitor inside the charger, which takes little time to discharge. This is the light when fully charged. It turns blue. If you see here, the light immediately switches on once it is dark, and the light is quite bright. This can be used as a bed light. Also, the light doesn't switch on even if it's dark when there is power. So that's all for today's video. If you like this video, you might like some of my other videos too. Check them out at Electronics Made Easy. Till then, I'll see you in my next video. Thank you.